This tutorial is a beginner's guide to start developing LLMs using LangChain. LangChain enables built-in applications that connect to external sources of data to be used with LLMs. LangChain libraries are made of chains, agents, and retrieval strategies that make up an application cognitive architecture. So to install it, the easiest way is to use Jupyter Notebook. I have an installation guide. I will be putting the link in the description. So to install LangChain, let's type pipe install LangChain. Okay. I already installed it, so no need to run it again. Okay. The first thing we will be doing is the simple example of using LangChain with an LLM. We will be using a local LLM, which is deployed locally on my machine using Ollama. So for this guide, we'll be using our Ollama locally. In order to install Ollama, there is a link here, and you can download Ollama for different architectures. I have it already installed, and I can show you Ollama list. I have these models installed locally on my machine. I have Ollama 2, Mistral, Gemma from Google. So we will be using one of those. So no need to have an API key. No need to have this API key from OpenAI. We will be using our own LLM today. Okay, so first step is to go ahead and import Ollama and specify the model. As I said, I have these models, so I'm using this one. I specify this model, and then we can invoke our LLM by asking a question or a prompt. So here I'm asking it, what is LangChain components? So since this is a local LLM, which is not having the recent up-to-date document, since it is a local LLM and don't have access to the internet, and it is trained on the answer can be wrong. So it tells us that LangChain is a set of reusable modular components for building conversational infrastructure and interfaces. It was developed by the Language Media Lab, Carnegie Mellon University. This is not correct. So this is not the LangChain we are asking for. It may be correct. Maybe there is another LangChain developed by the Carnegie Mellon University. I don't know. So we can guide its response with a prompt template. So here we just ask one question. Now we can specify a prompt template. So rather than each time we want to ask the LLM a question, we need to prepare a long prompt to guide its response. We can specify this template and we can reuse it later on. So to do that, we can import prompts from LangChain core, and we create a prompt variable from the chat prompt template, and we specify the prompt template for the system. So we are telling the LLM that you are a world-class technical documentation writer. So write as if you are a technical documentation writer. And here is the input. So the input is our prompt. When we invoke this prompt with a message, the message will go here. So we combine these two in a simple LLM chain. So we are seeing now why we call it LangChain. So we are chaining a lot of components in order to get the job done. So the chain here is the prompts plus the LLM. So we invoke the LLM using the chain and ask the same question. So now we are putting the question inside the chain. Invoke, the input is what are LangChain components, the same question. So this question will go here, and the whole prompt will be passed to the LLM. So now the answer is slightly different. Now it says that as a world-class technical documentation writer, I'm happy to help you understand the components, blah, 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 blah. Okay, It's still talking about the Carnegie Mellon stuff, so it's not what we are asking. Now we can add a simple output parser to convert this chat message into a string. So here, if you see, this is normally a chat message, but not the case. So this is not relevant. It is already parsed as a string. We have a string instead of a message. No, we can delete this. Or we can keep it. Maybe later on we want to specify another output, so we can chain the output to the LLM. So same thing, same result. So basically now we have successfully set the basic LLM chain. However, in order to properly answer this question, we need to provide additional context for the LLM. This is the fun part. This is when we specify which source of information the LLM should be using to answer these questions. Here, this is what we call a retrieval chain. So retrieval chain is retrieval is used when you have too much data to pass to the LLM directly. And so instead of, I don't know, passing big set of documents to the LLM in order to complement its knowledge base, we specify a retrieval chain. So we can use this retrieval chain to fetch only the most relevant pieces of information. A retrieval can be backed by a source of information. So we can put our information into an information source like an SQL database, a set of PDF documents, or some websites on the internet. However, this information needs to be translated and stored into a vector store to be used by the retriever. So this is where the retrieval store and embeddings come into play. We won't talk about this today, but we will be using them, and I will be explaining them in a later video. So let's see how to do it. We will be using the internet as our source by loading information from the LangChain docs website. And to do this, we will be using a library, a Python library that do just that, which parses web pages, called Beautiful Soup. So we can install it by using pipe, and then we can use a document loader from the community to import web loader object. So this web loader object basically will take a link, a URL, and build a loader. Build our loader. Then we can invoke loader.load to fetch information from this website and put it into docs. Next, we need to index it into a vector store. This requires a few components, as I said, a few components, an embedding model, and a vector store. For embedding model, we use our Olama embeddings. To do that, we import from embeddings from the community, the Olama embeddings, and we create an embeddings object. Next, once we have our embeddings, we need to ingest our documentation into vector store. We will use a simple local vector store. So here, Face, it's a simple vector store that we will be using here. So Face is a Facebook AI similarity search, which is a library for efficient similarity search and clustering of dense vectors. So basically, the embeddings will create vectors from our data and store it into Face. And we can use it to retrieve information based on the similarity. So we install Face CPU, okay, and then we create our text splitter. So before putting documents into a vector, we need to split the documents. using a text splitter. Here we use a recursive character text splitter that will split our text, and it will create a set of documents that we will store in Face using the embeddings that we create. Now that the data is indexed into a vector store, we'll create a retrieval chain. This chain will take an income question, look at look for relevant documents, then pass those documents along with the original question into the LLM. So here we create a prompt as we did before, but this time we will create from a template. This is our template. So answer the following question based only on the provided context. So we ask the LLM explicitly that we will be giving you a context, which is our embeddings and vectors and the information fetched from the website. And this context will go here. And the question will come from the input. And we build our document chain, create subdocument chain from the LLM and the prompt here. Now we need to create a document retriever from our vector. We built our vector that contains vectorized information. Now we will build a retriever from that vector. So we use vector as a retriever, and this retrieval chain will be created by this method based on the document chain and the retriever. Now we can invoke the chain. It should return a response from the LLM as a dictionary with the answer as key. Okay. So response retrieve chain invoke. So for input, we give it the question, what is LangChain components? And we check what is inside this response. Now we can see that it is using or referring to the correct LangChain in our case. So based on the provided context, LangChain components refer to the building blocks of a LangChain network. These components are the individual elements that make up the network and enable it to perform its intended function. So the answer now is more accurate. Now that we have our LLM using personalized context and prompts, we can start touching the power of LLM. Now that we have our LLM using personalized context and prompts, we start touching the power of LangChain. However, we are barely touching the surface of what we can do with LangChain. So in the next example, we will be using conversational retrieval chain. So why? So up until now, we were asking one question and the LLM will answer it. If we ask a question related to the previous one, the LLM will have no memory and no context is saved between the questions. This is where conversational retrieval chain come into play. So to build our conversational retrieval chain, we can reuse the create retrieval chain function. However, we need to change two things. The first one is the retrieval method should take the whole history into account. So not only the context, but the history of the chat. And the final LLM chain should likewise take the whole history into account. I'm making a lot of errors here. Okay, so we update some things. Here we use a message placeholder and we will replace the chain by a create history aware retriever. So the prompt in this case will take the chat history in a variable called chat history and the user input, and we will ask it, given the above conversation, generate a search query to look up in order to get information relevant to the conversation. So now the retrieval chain is created from the LLM, the retriever, and the prompt. And to test this, we pass in an instance where the user is asking the following question. So, can LangChain help create personalized LLM applications? Supposedly the AI message was yes. Now we ask another question. Tell me more. So it will be aware of the previous message, and now we are asking tell me more. And the response is this return document using LangChain to personalized application. This is because LLM generated a new query combined the chain. Okay. So we have a document that contains LangChain history. Now we can have it retrieve. We have this retriever. We can create a new chain to continue the conversation with this retriever documents in mind. So if we ask the same question, now we tested the new retriever chain. Can LangChain help create personalized LLM applications? Tell me more. Okay. The input is tell me more. Now the answer is, of course, I'll be happy to help you understand how LangChain can assist in creating personalized LLM applications. Okay, blah, blah, blah. So this is a coherent answer. We successfully tuned our retrieval chain into a chatbot. Yay! Now let's talk a little bit about agents, which is a powerful feature of LangChain. So up until now, we created our own steps while interacting with LLMs. In other words, we are asking the questions and the LLM is basically answering these questions. With agents, we can ask the LLM to ask its own questions. If there is a chain of questions that need to be asked in order to achieve the intended goal or to answer a question, the LLM will generate those questions and will answer them. So this is the goal. So here, basically, we will be use a local agent that will go to the internet and look for information. And based on this information, it will try to answer our questions. So without diving deeper into the details, agents need a whole video by themselves. So basically, we will create a hub and we will use another model just to illustrate. Here we will use Mistral. We create the tool. The only tool we give this agent is the capacity to go and ask questions to a search engine, which is called Tivoli. We create the agent. We give it a prompt model. So here we use the hub to create a prompt without instead of creating it ourselves like we did before. So the agent is created by create self-ask with search agent, which takes these tools, and we run the agent. To run the agent, we call the agent executor with the agent, the tools. We specify that we want details in the answer, and if ever there is questions, just handle them. These questions can come from different places because the agent will ask questions and it will receive information and it will use this information to ask other questions, and a lot of things can happen from these answers. So basically here we are telling just ignore if there is parsing errors and go ahead. So we invoke the agent, we ask it a complicated question that cannot be looked for just like this, like which country is bigger, Morocco or Sweden, in terms of area? So the agent is executed. He said, yes, I can provide some context. So follow up. He asked one question: what is the total area of Morocco? So the answer is the total area of Morocco is 400,000 something as of 2021. If the area will change, yeah, maybe. Based on data from the World Bank Collector and Development Indicator. Another question: what's the total area of Sweden? The area of Sweden is 450. Oh, it's almost the same. Blah, blah, blah. So the final answer is Sweden is slightly larger than Morocco in terms of area. Sweden's area is about 5,000 square kilometer larger. Okay, nice. So that's it, folks. That's our introduction to LangChain and how to start our journey with LLMs using LangChain, so that we can build our own AI or interact our own AI. And here we use it locally, and we stepped above the simple use case of asking questions and getting answers. Here we are specifying which sources of information the LLM should be using, and we are creating an agent that can ask questions and answer them, and do a series of question answer to retrieve the information needed. Okay, so that's it for today. Thank you for watching, and see you next time. Bye.